Hey, welcome everyone to our webinar today on single skin metal siding, performance and design considerations. It's being presented by AEP Span. I'm Paul Deffenbaugh. I'm the editorial director at Metal Architecture Magazine, and this webinar is part of our webinar series that we do here, and we're glad you've joined us. I'm going to turn things over to Tyler Murray, today's speaker, in just a moment, but before I start, I want to preview how we're going to work. The webinar is going to last an hour. Tyler's going to take questions at the end of each section. There are 4 sections, so if you have a question, enter on your panel there, and I'm going to monitor them, and then I'll come back in at the end of each section and raise the question with Tyler. Ask as many as you can. We keep track of all the questions that are asked, so that even if we don't get to it during the webinar, you can get a follow-up after the webinar is over. A lot of you will want to know how we're handling CEUs and certificates. It's all being taken care of automatically, but please allow 7 business days for everything to be processed. Glad you joined us. Let me turn things over to Tyler. Tyler is the technical service representative for AEP Span. He oversees the weather tightness warranty program in the greater Pacific Northwest. He's been in the construction industry for 20 years with a concentration in roofing installation and inspection. He's got tons of certificates in his field, as well as a deep understanding of the products associated with the roofing industry. And he also holds the OSHA 510 outreach training card. Tyler's experience in the industry has included roles such as a journey level roofer, estimator, project manager, and prior to coming to AEP Span, he worked as the lead technical representative in the Northwest for a worldwide roofing products manufacturer. For them, he was responsible for job site inspection, final roof inspections, warranty claim investigations, and product training for installers, as well as technical training for other technical representatives throughout the United States. Tyler, you got a great program to go here. Let's start it up.
All right, Paul, thanks so much. Good morning, everyone, or afternoon, depending on where you are. Like Paul said, I'm good. I'm big on questions. So at the end of each section, if you guys have anything, that you think that I forgot or anything that you'd like to get touched up a little more on, don't hesitate to ask. I'm going to jump right to it and just get through. This is the single skin metal siding, performance and installation considerations. This is our course number. It's a continuing education numbers and the learning units that we're going over. Single skin metal wall siding is a great example of continued advancement of building products in the architectural market, driven by a more sophisticated designs and greater emphasis on sustainable building practices. Emerging trends shape the architectural market as people become more aware of the environment around them, and single skin panels are on the forefront of those trends. This course will explore the different types of single skin metal siding. We'll go over some specification details as well as the performance and design considerations. At the end of the course, I hope that you guys will be able to understand material inputs and performance attributes for architectural single skin metal siding. We want to talk about the environmental impact and the sustainability of this siding. Understand the types of single skin siding and the specification considerations. So which types of single skin siding get specified in which areas. And then we want to learn the design and installation considerations that facilitate a successful siding solution. So this learning objective 1 will focus on material inputs and performance attributes. So single skin metal siding is made up of several material inputs, and each material performs a specific function. We're going to start at the base metal and work our way through the layers of coatings used on single skin metal panels. The base of a metal panel is made of either steel or aluminum, and both offer long-lasting performance. Steel panels are offered in a range of gauges or thicknesses, starting from 18 gauge being the heavy gauge to 29 being the light gauge. The industry standard thickness for aluminum panels are generally offered in 050, 040, and 032. At the end of its useful life, metal siding panels are 100% recyclable. The coatings do not interfere with the panels being recycled. So the next layer of a single skin metal siding panel is the metallic coating, which provides corrosion protection. For steel panels, there are two types of metallic coatings. One, there is an aluminum zinc coating, and two, a galvanized coating. An aluminum zinc coating is made up of 55% aluminum and 45% zinc. This coating is known in the market as galvalume or zincalume. The aluminum 55% component provides a barrier protection and is inert, meaning it does not react and it does not corrode. The zinc 45% provides the sacrificial characteristic that protects the material's cut edges. Typically applied to metal siding panels in 22, 24, 26, and 29 gauge. Galvanized coating is 100% zinc coating and comes in different coating thicknesses, with the most common being G60 and G90 galvanized. G90 being the thicker coating. Typically, there is no corrosion warranty offered on a galvanized substrate. This is typically applied to metal siding panels and from 18 gauge to 29 gauge also. Zincalume or galvalume coating offers a higher corrosion performance over galvanized. Aluminum panels do not require metallic coating because aluminum material naturally develops a durable oxide film on the surface when exposed to moisture and is nearly impervious to further corrosion. After the metallic coating, there's a pre-treatment coating which allows the paint to adhere to the metal or aluminum substrate. The primer coat allows for further adhesion of the cool top coat or paint finish. The cool top coat color is the top layer and is the last top layer, which is the paint color. It not only contributes to design, but is also has important energy efficient attributes, which we will cover in a couple slides. And the bottom layer is called a backer coat, which is an inexpensive polyester paint system, and it's used to protect the backside of the panels during installation and when they are stacked together for shipment, which helps prevent road abrasion. So single skin metal siding panels are also available in galvalume or zincalume coating with a clear top resin coating. The clear coat will offer a sheen that enhances the natural characteristics of metal, offers a bare steel aesthetic. It also resists scuff marks, fingerprints, allowing you to maintain a consistent satin smooth finish. It also offers energy efficient attributes and can also be painted over without a primer. This is a visual order of the three paint systems from a performance perspective. We like to use the good, better, best model. The polyester paint system is the least expensive paint system used for gutters and downspouts, residential trim, and as a backer coat for metal siding panels and metal coil. By using polyester paint coat on the back of metal panels and metal coil, it prevents transit abrasion to the top finish coat during shipping and to the backside during installation. An SMP paint system offers a better resistance to color chalk, and fade compared to a polyester paint system and is a versatile paint system. It's used primarily for commercial projects. Comes in a wide range of cool colors with energy efficient attributes. An SMP paint system offers better chalk and fade resistance compared to a polyester paint system, and it's less expensive than PVDF coatings. Typically provided with film integrity, chalk and fade warranty. It has a longer film integrity and chalk fade warranty than a polyester paint system, and it's also typically used on lighter gauge metal siding. A PVDF paint system is a premium system that provides outstanding resistance to ultraviolet radiation with exceptional color retention, resistance to chalk, and chemical degradation. It is used on high-end architectural products or in aggressive environments. This paint is often referred to as Kynar 500 or Hylar 5000. Comes in a wide variety of cool colors also with energy efficient attributes. Bright and rich colors with a clear top coat to assure long life performance. Typically has the longest film integrity, chalk and fade warranty, and typically used on educational, public government, healthcare, and commercial projects. So the marine paint systems, the PVDF marine paint system is also available for severe corrosive or saltwater environments. There are two PVDF marine paint system warranty options. There's a 15-year limited warranty with a high build primer applied under the top color. The high build primer is applied under the top color coat. Also a 20-year limited warranty with high build primer applied under the top color coat and a clear coat are required. The PVDF paint system also comes in a wide variety of cool colors with energy efficient attributes. It can be applied on as aluminum zinc coated steel substrate or your typical aluminum substrate. So I've been using the term cool color quite a bit during this presentation so far, and here we're going to get a chance to learn what I mean by that. The same paint systems used on metal roofs are used on metal siding panels. The first bullet point talks about solar radiation. The solar radiation reaches the Earth's surface in three distinct wavelengths. It's the IR radiation that generates the heat on a surface. The pigments in the paint system have been altered with special IR reflective pigments that stay cooler than traditional pigments. So when the IR radiation wavelength hits the surface of the siding, the paint system allows for solar reflectance and thermal emittance and contributes to keeping the building cool, conserving energy, and saving on energy costs. The question of light reflectance values does come up occasionally, and so here's a quick overview. Light reflectance is the visible light reflected by a surface. The LRV is measured for the amount of visible or usable light that reflects from a surface. The higher the number, the more visible the light that is reflected. A visual example is when glare is reflected from a surface. Typically, lighter colors will have a higher value than dark colors, but texture can impact LRV as well. A manufacturer should be able to provide the LRV for a specific color. While there is some overlap between LRV and solar reflectance value, SRV, as many coated surfaces may have similar LRV and SRV values, they are not the same measurement. Solar reflectance value, or SRV, measures the amount of total solar radiation, infrared and ultraviolet, that is reflected from a surface. The SRV measurement is expressed as a percentage from 1 to 100. The higher the number, the more solar radiation that is reflected, the higher the SRV value, the cooler the surface stays in direct sunlight. That's the end of learning objective 1.
Hey, great, Tyler. Thank you very much. I've got a couple of questions for you here, if you have a moment. The first one is, are all the paint systems that are listed in the presentation here typical for metal applications, and are all of them considered to have a cool rating?
Yep, they are. The three systems described in this presentation are most commonly used paint systems for metal applications. All three are formulated with the same cool pigments and should have published reflectivity and emissivity values from a reputable manufacturer. What differentiates one paint system from the other is weatherability. Chalk and fade resistance from a high-end coating such as Kynar is reduced when you go to a low-end coating like polyester.
Great, thanks. I've got another question here from Kyle. He says, with the clear coat and the paint over top of it, does the clear coat need to be roughed up to prep for the paint?
I wonder if he's talking about post painting or.
Yeah, I believe so. Yeah, because it would be something that the manufacturer would be handling otherwise.
Right. Yeah. Yeah. The surface needs to be prepared, but I don't think that they scuff it before they use some chemicals to clean it real well before they paint it. But I do not believe that they scuff it prior to post painting.
Okay, and Kyle does clarify he was talking about post manufacture.
Yeah, I do not believe so. But I'm not a post painting expert, I suppose. So that may be. I guess that would kind of be up to the painter.
Okay, great. And final question here: is there a threshold for the LRV before it becomes a danger to the public walking or driving by? You know, we've seen stories about buildings that are so reflective they melt plastic
Right. Yeah.
nearby.
I don't know that they've calculated a number for that. I just think that I mean, I'm sure someone has at some point, but I don't know if there's a threshold number for that. It's more of a visual situation. If you have a building that's reflecting down onto the public or onto another building surface, and you do hear stories about that, where mostly with glass applications, but I have heard of some metal siding projects that are kind of highlighted in the city because of the fact that they do have a high reflective value, you know, down on different projects and different buildings.
Great, thanks. Folks, keep putting in your questions. We've got more than we can answer real quickly here, but we'll save some towards the end. Thanks.
So on to learning objective 2. We begin this learning objective by highlighting the research on cool sidings conducted by the Lawrence Berkeley National Lab, referred to as LBNL, which is the nation's scientific research lab for the U.S. Department of Energy. They explored cool siding benefits, technology, and infrastructure in a research project sponsored by the California Energy Commission's Electric Program Investment Charge. There is a high level of overview from that research. They evaluated the annual energy cost and emission savings in all California climates and the U.S. climate zones 1 through 4 from 2015 to 2018. They used the program to model energy consumption from a variety of project types, such as multifamily, various office buildings, and hotels. They used the program. The findings from the research indicate that cool siding saves energy, money, and carbon dioxide in warm climates. It mitigates the urban heat islands and tends to stay clean. Cool coatings on metal siding products are available today, often at no extra charge. The LBNL seeks to expand and enhance the cool siding provisions found in U.S. codes and standards and green building programs. Today, cool sidings are currently found in U.S. codes and standards and in the green building programs. The LBNL is developing new cool siding measures in codes and standards and green building programs. They're working on establishing a cool siding product rating system and modeling on or expanding the existing programs. And then the Cool Roof Rating Council is also proposing to create a rating program for exterior siding products similar to the roofing program. So we will continue to monitor its progress. Today, single skin metal siding panels contribute to green designs and certification programs, such as the Living Building Challenge, LEED V4.1, Green Globe, and then the collaborative for high performance schools. From a green building certification standpoint, we've conducted a comprehensive assessment of LEED V4.1 to determine how metal roof and siding products could contribute to green certification programs. Although this assessment is based on USGBC's LEED V4.1 system, several of the categories in LEED are similar to the other green building certification programs, light green globe, and CHIPS, Collaborative for High Performance Schools. Depending on the design of your project, metal siding panels can contribute to green designs and certification programs. For the Living Building Challenge, building products fit into the materials pedal red list for the Living Building Challenge. To be eligible, a manufacturer has to disclose 100% ingredients down to 100 parts per million of the materials and chemicals on the red list. Today, metal siding panels can meet the LBC red list free criteria. Metal siding panels coated in zinc aluminum, also referred to as galvalume, with clear protective resin coating meet the LBC red list free criteria. These can be ordered as a standard at no extra cost. It also offers a natural steel aesthetic design, and it's available in multiple profiles. Metal siding panels with cool painted coating also meets the LBC red list free criteria. There are some challenges with painted metal siding panels. There is hesitation by coating manufacturers to provide the proprietary information on paint formulas. Standard corrosion-resistant primers contain low levels of chrome. Factory-applied paints often contain a curing chemical that, while on the red list, is reacted and eliminated during the curing process. Despite the presence of a few red list substances, pre-painted metal is inherently safe and does not pose a risk. The industry has been working through this concern, and there have been some performance trade-offs, which until recently was significant. There is progress, and we are actively pursuing a suitable replacement. Okay, that was the end of learning objective 2.
Thanks, Tyler. Just a couple of quick questions. Do you know of any single skin products that offer FEV paint as or FEV, I can never remember how it's pronounced, versus PVDF? I know you're not a paint specialist, but I'm just curious.
Come again with that question. I guess I didn't.
Whether there are any single skin products that offer FEV coating paint as well as PVDF, excuse me. I'm getting my acronyms messed up.
I'm not sure that I know the answer to that.
All right, so I'll ask this person to follow up with us later.
Absolutely.
And the other question I have here is with the current LEED version 4.1, can metal siding contribute more points than were eligible in previous LEED versions? Do you know what the change has been?
Yes, they can. Previous LEED requirements only allowed points for recycled content, and heat island. And then the regional material needed to be sourced within 500 miles of the project. So the current LEED V4.1 has more categories for LEED point accumulation. The newer ones include energy and atmosphere, materials and resource, and indoor environmental quality. Walls are still not eligible for heat island effect credits. However, we feel that once the CRRC establishes a rating system, that will change.
Thanks very much. And keep the questions coming in, folks. Go on ahead there, Tyler.
Learning objective 3. Metal siding is identified and characterized by its attachment. There are 2 types of metal siding: exposed fastened and concealed fastened siding panels. Exposed fastened siding relies on visible fasteners to secure the material to the structure. A concealed fastened siding has no visible attachment points, and this type of siding can include direct attachment or clip attachment to the structure. Exposed fastened siding relies on visible fastening device to secure the material to the structure. Standard or common gauges for exposed fastened metal siding panels tend to use a thicker material to accommodate the requirements for positive loading only or areas near heavy human interaction. Steel 29 through 22 gauge are industry standard. A corrugated profile could be produced from industry standard aluminum thicknesses of 050, 040, or 032. Typically speaking, the profile drives the thickness of the aluminum that is used. Exposed fastener profiles are offered in a range of ribbed profiles in light and heavy gauges. There's a couple photos of some storefronts that you guys might recognize. Used in a wide variety of different applications in the world today. So some concealed fastener panels provide their own unique look and texture when selected as a siding. Concealed fastening siding provides clean lines by eliminating the need for exposed fasteners and are often chosen over exposed fastener panels where weather tightness is a factor. Panels can include a direct attachment or clip attachment of the siding to the structure. 24 gauge and 22 gauge steel are the industry standard. And then concealed attached profiles can be produced from the industry standard aluminum thicknesses of, again, 050, 040, and 032. And again, the profile drives the thickness of the aluminum selection. It's a few options of a concealed fastened siding system. A couple more. Performing Arts Center there. So now we'll move on to expansion and contraction. Environmental factors driven primarily by temperature fluctuations cause panel assemblies to expand and contract. For steel panels, generally 1/8 of an inch of expansion and contraction per 10 foot of panel is a common rule. For aluminum panels, the thermal movement is almost twice the rate of metal, making upwards of 1/4 inch per 10 feet of panel length. Most concealed fastener assemblies allow for thermal expansion through the use of single piece clips that slide within the panel seam. Exposed fastener profiles do not accommodate for thermal movement. The fastener mounting hole may stretch or tear, ultimately resulting in leaks. For the right applications, there are many benefits to exposed fastener profiles. It offers a classic design. It's offered in a large range of finishes and textures. A lot of people like it because of the ease of installation. It's definitely easier to repair and replace. This makes this a practical option in high traffic areas where panels could be more prone to damage. With proper sealant placement, exposed fastener panels can provide adequate air and water infiltration control and may have been tested and approved through the ASTM method, ASTM E283 air and E331 water. There are 3 main laps utilized in metal siding panels. The first is a traditional side lap where one panel rests over the adjacent panel. This lap is most commonly found in exposed fastener siding panels. Field applied lap sealant is required to keep the side laps watertight. Second lap condition is called an integral seam. An integral seam utilizes the male and female lap engagement. The panel attachment is achieved by directly fastening through a nailer strip on the female leg. The male leg is then interlocked, concealing the attachment points. Some integral seam panels offer clip attachment as well for higher wind load resistance. Integral seam panels are typically offered with factory sealant in the female leg, or the sealant can be field applied. A third lap condition is referred to as a hook seam lap. A hook seam utilizes 2 reversed rolled hems that positively engage each other. The panel attachment is achieved by direct fastening through the nailer strip on the mounting flange of the panel or with a clip that is attached to the substrate. The other side of the panel has a leg or a hook that is interlocked which conceals the attachment points. Some integral seam panels offer clip attachments as well and are available with factory or field applied sealant. Each option offers the designer a choice depending on the project's structural and aesthetic needs. Integral hook and seam panels generally have a substantially higher structural performance when used with clips. They also offer better weather tightness than exposed fastener panels due to their concealed attachment and may have been tested and approved through the ASTM method. Integral hook and seam panels are generally preferred for the most visually demanding architectural applications, and they're easy to install. The one-piece clips used with the hook seam panels are often simple in design and provide unlimited thermal movement because the panels expand and contract within the clip. And that's the end of learning objective 3.
Great. Hey, thanks, Tyler. We've got a couple more questions here. In some of those photos on some of the slides you just went through, it looks like standing seam roof panels are used in wall applications. Is that correct? How's that work?
Yeah, that's correct. That's we see it a lot. It's this presentation is primarily centered around designed wall panels. Standing seam roof panels are gaining popularity in the wall market, actually. They offer concealed attachment and clean vertical lines. Lots of the reputable manufacturers have details for installing a standing seam roof on a wall application.
Great, thanks. And I've got another question here, and I'm going to kind of broaden this question. I think it's aiming at a warranty issue. The question is, what's the average lifespan of the exposed fasteners, rubber gasketed screws? So the rubber gasket, I think, is that maybe they're concerned that it's not going to last as long as the other materials and might be a weak point.
Yeah, that is correct. And what ends up happening mostly is the expansion and contraction in that material. It starts to waller out a hole in the metal itself, which in turn plays damage on that rubber gasket. Depending on the screw, obviously, the more money you spend on your screws and making sure that rubber gasket, they're using neoprene or EPDM these days mostly. But I would say, 15 to 17 years, if I had to throw a number on the life expectancy of a screw.
And I have a follow up on that myself because I'm curious about it. Oftentimes we hear about the failure of these screws because they're not properly installed. They're either overdriven or underdriven. Is that what you see most often in the field?
Yep, I sure do. That's a constant in the through fastened metal market. It really is. It's something, if you overdrive that screw, obviously you're putting some unneeded tension on that rubber gasket, and then as the panel does expand and contract, and then that rubber gasket will wear out sooner. And then an underdriven screw at the same time doesn't put enough, because it's a compression based seal. So you're absolutely right. That is what I see most often.
Thank you. And one final question from this section. It's asking about in rain screen installation process. Is the sealant at joints vital? Because water has an easy way out and down with the rain screen. So do you need to have that seal at the joints?
You do not.
Okay.
Yep. Nope. I mean, that would be the answer to that question is no. Because of the rain screen application and because of the way that rain screen is built, you would not need factory or field applied sealant in that application, unless for some reason you are wanting to keep the water from getting in there. But that's sort of the point of a rain screen application, is to let the water flow through.
And I'm going to do one more follow-up question from somebody who just put this through about the exposed fastener screws. Why then, if there's this 15 to 17 year point, would you choose an exposed fastener versus a concealed fastening system?
Typically speaking, from a durability standpoint, it's a better panel. Depends on the application. In an agricultural situation, or if cost is a factor, the difference between an exposed exposed fasten panel and a concealed fasten siding system, the difference in cost is substantial.
Thanks. And I'll just comment on that. We see at Metal Architecture Magazine lots of projects these days that do have exposed fastening. It just seems like it's a kind of a design trend that's happening. Thanks very much, Tyler. That's the end of that one. Go on to the next.
Okay. So learning objective 4 will be the vertical and horizontal applications. Single skin metal siding panels have the ability to be installed vertically or horizontally, or a combination of both, which offers beautiful design options. The vertical applications offer the installer flexibility in the installation by allowing the panels to be installed left to right or right to left. Horizontal applications are a bit different. When installing integral seam panels, they are intended to be installed from the top of an elevation down due to its seam configuration. You get a lot of pushback on this particular installation method because it kind of goes against what siding installers have been taught and learned throughout their years in the industry. But these integral seam panels do get installed from top to bottom. If integral seam panels are installed from the bottom up, the female leg can trap the runoff from the rain, which can compromise the weather tightness over time. And you can see from this picture here how it's just how the panels are made, and if the water stayed trapped in the bottom part of that little panel, it starts to cause trouble over time. Traditional side lap seams and hook seams are just the opposite of an integral seam panel. The hook seam panels are required to be installed from the bottom of an elevation up, which allows runoff to flow over the lap. Installing from the top down can compromise the weather tightness again over time due to exposed seams. It's the same as the integral seam panel. It's just the opposite. It'll hold water in that seam. It's important to take these details into consideration when selecting an appropriate product for a specific application and the phasing of installation. Install on a wide variety of substrates, including but not limited to dimensional lumber, plywood, OSB, C or Z purlins, half channels or furring, steel deck, hot rolled structural steel, and something I don't see very often, but concrete or masonry. So the fastener specification is pretty critical. Specifying the fasteners that hold the panel or clip to the substrate is an important component of a properly designed panel assembly. Fastener size is generally defined by the panel, clip fastener clearances, and substrate being utilized. The manufacturer should include the improved fastener size based on the panel in their approval report, in their installation guide, or by contacting the panel manufacturer's representative directly. It's the underlying substrate type and thickness that determines the fastener length, point, and thread type. The fastener should be obtained through the panel manufacturer when possible to ensure that the appropriate fastener is being used so the overall panel assembly capacities can be met. There are several key certification bodies who issue product approval reports. So IAPMO does the evaluation reports, the ICC does the evaluation service reports, Intertech does research reports, and UL does the evaluation reports. The process of evaluation report is as follows. It starts with the certification body who develops evaluation criteria. They have a document which defines the requirements for products to meet code provisions and for the conditions where codes do not address the necessary requirements. Next, the manufacturer seeking the approval report submits all independent test data, performance calculations, etc., as required by the evaluation criteria. And then lastly, the certification body evaluates a manufacturer's performance data against the requirements stated with the evaluation criteria. So it's quite a lengthy process to get approval reports built for your products. If approved, the certification body publishes the product approval report. IAPMO-UES is currently the only known certification body that has an evaluation criteria for metal siding. Metal siding and roof panels are prescriptively defined within the building codes and generally do not require a product approval report. However, manufacturers who have approval reports make them significantly easier to work with, as all published performance data has been thoroughly evaluated by an accredited certification body. It's an example of a evaluation report. So the positive or inward loading based on panel gauge and span, and then the negative or outward loading based on gauge, substrate, fastener, and fastener spacing. Moving on to underlayment. Specifying underlayment for metal siding also comes down to often comes down to three basic needs. The first is to dry the building in so other work can proceed within the building, and if inclement weather hits, the building envelope is secure. The second is to protect against the chance that moisture will penetrate the metal siding system and act as a secondary moisture barrier. And the third is to allow a means of escape for backside condensation, which may occur in certain metal siding applications. This condensation must be directed out of the system. Siding underlayment is typically required to be semi-impermeable. This means that the underlayment will allow the passage of vapor in one direction, which is from the inside out. The underlayment does not allow the passage of vapor or condensation into the building. There is a class rating system for siding underlayment, which is climate zone driven and should be considered before choosing an appropriate underlayment for a specific project. We'll go over the underlayment class rating system. Class 1 has less than 0.1 perm, which is impermeable, a vapor barrier. Class 2 is a 0.1 to 0.1.0, which is semi-impermeable. And then class 3 is considered vapor permeable and can range from 1 to 10. ASTM E96 determines the perm rating for underlayment. So the appropriate underlayment, siding vapor barrier, is relying upon external internal siding assemble, cavity, and insulation. The underlayment used for concrete block is different from wood, which is different from a rain screen system. Type 2 or type 3 vapor barrier is typically required, giving a vapor perm rating of up to 1.0. The exceptions being coastal environments, refrigerated buildings, indoor pools, amphitheaters, or structures that use a non-typical deck or siding material such as tectum or lightweight concrete. Polyethylene or foil-faced underlayment is acceptable for external applications, but should not be used on the interior as it facilitates molding. Climate zones also need to be taken into consideration as they contribute towards the selection of an appropriate perm rating for underlayment. I'm going to jump into some details. These are typical base trim details for vertical and horizontal applications. Careful consideration should be taken to ensure that all base conditions are installed above grade to avoid any potential issue with standing or ponding water. Standing moisture at the base condition can promote premature material corrosion. Note that there's a 1/4 inch gap required between the base flashing and the bottom of the panel to allow for any weepage. Material should also avoid direct contact with mortar and concrete. Aluminum zinc should not be used on, in, or around concrete or mortar. Concrete and mortar are highly alkaline environments. Bare aluminum zinc and painted aluminum zinc sheets suffer rapid corrosion when when in contact with mortar or concrete. For vertical applications, it is important to note that from a detail and design perspective that the siding base trim is sloped away from the building. The photo with the gray siding shows what a cut panel edge terminated to a J trim at the base of the siding can lead to panel edge corrosion. J trim used at the base of a siding will trap moisture and act as a gutter. This can lead to premature panel deterioration. A siding base trim that is sloped away from the building is critical. This is a photo of a typical parapet cap. This detail with siding panels installed in a vertical orientation. Notice there are some slope built into the parapet cap itself to prevent ponding. Also, the exposed exterior of the parapet is concealed, fastened, and attached to the cleat. This allows the parapet cap to show no visible fasteners on the exposed side of the cap. Only the interior side of the cap flashing utilized an exposed fastener that is not possible to engage both sides of the parapet cap with the cleat. These are typical inside and outside corners. They utilize flat trim pieces that cover the factory cut edge of the profile. The trim pieces are typically attached to the high ribs of the panel with blind rivets at 12 inches on center to minimize the appearance of exposed fasteners. Profiled closures are installed between the panel and the corner trim to prevent wind-driven particulate or pests out of the condition, essentially making for a weather-resistive seal at the corners. Some photos of some typical inside and outside corner details. They will also give a vertical line break in the profile, as you can see. The size of the corner trim can be adjusted to work with desired aesthetics of the project. Typical is in the 4-inch by 4 by 6 inch range. Another option for inside and outside corners are what's known as a profiled or mitered corner. This option gives the appearance of the panel cleanly transitioning around the corner. This method is only typically used on horizontal applications. Typical window, door, or louver head condition with a horizontal panel application. A header trim is installed prior to whatever might be installed at this condition. This allows for a proper seal between the header flashing and the opening frame. Just like the base detail, a 1/4 inch gap is needed to allow for weepage between the panel and the header trim. This is a typical jam condition on a horizontal application that has the trim installed prior to what is being installed in the opening. The panel is then tucked behind the trim and secured with rivets at 12 inches on center. Profiled closures are used to seal the gaps. This is a typical sill condition shown again with the trim installed first and the panel is tucked under the side enclosure and trim is attached with rivets. What is a little bit different about this detail is the panel itself. You will notice the addition of a Z metal behind the panel. This is there just in case you cannot get a full width panel into the condition because of layout. The edge of the panel may need to be cut off to fit, and the Z metal is there to support an otherwise unsupported cut panel edge. It's a typical soffit transition. This is a unique condition that would be a siding panel or fascia panel to soffit transition. It is handled the same as a typical base condition with one exception. The cover trim is an adaptation of the base trim with an extra long return to allow for an overlap onto the desired soffit material. Placement of the cover trim should be considered carefully as a sufficient gap will be needed to account for the thickness of the soffit material that is going to go behind it. Sequencing of this installation would be the soffit material first, then the cover trim, followed by the siding or fascia panels. Siding penetration details can be a bit tricky and truly rely on the skill and attention to detail by the installing contractor. Typical details are achieved by mounting a flat a flat plate onto the surface of the panels to allow the mounting of various lighting or other mounted fixtures. Most siding penetration mounts need to be field fabricated after the panels are installed to ensure proper placement of the mounting plates. Rib layout often affect the size of the mounting plate that are required. So in-laps for nestable products are fairly simple to achieve. The panel will lap just one over the other. This is known as nesting. Nestable products are typically exposed fastener profiles. Concealed fasten systems cannot typically utilize a nestable in-lap due to the panel layout and profile complexity. These types of overlaps are usually between 3 and 6 inches and sealed within the lap with 2 beads of gunnable non-skinning butyl. Nestable overlaps give a clean and straight lap line in an exposed fasten profile. Here's some non-nestable panels. Unlike nestable profiles, non-nestable profiles require through fasten trim pieces to achieve the panel laps. This may work with desired project aesthetics. Flashing lap lines can be coordinated in a way as to match siding opening locations and floor levels on multi-story projects. They work with both horizontal and vertical panel orientation. The two pictures show the vertical lap lines with horizontal and vertical applications. These are the in-lap details, or a butt splice with a splice plate installed behind the panel. This would be used on an application where different size and color profiles are going to be located on the same elevation, or where project aesthetics will not allow for a splice trim. Here's some photos of the splice lap shown in unique color mix project that also has a long siding run. Careful consideration should be taken when selecting this kind of lap. As you will notice, panel in variations can make the lap lines visible. Vertical panel orientation with horizontal trim lap lines gives a unique appearance, and lap lines can be laid out to match siding openings or floor levels on multi-story projects. And that's it.
Great. Hey, thanks, Tyler, for a wonderful presentation. I've got a bunch of questions on a lot of technical stuff that, given my lack of technical experience, I'll probably struggle through. But first of all, how important is it, or is it necessary to work with a manufacturer with an engineered evaluation report for their products?
Absolutely. It's not critical, but it does help move things through the plan and check phase of a project. Metal wall panels are defined in the building code and are not considered an alternate means or method, which would require an evaluation report. But by having this report, all the performance data of the profile is published for section properties, as well as negative outward loading, which is your wind uplift resistance, and positive loading, which is the live load, such as someone walking on the roof or equipment being installed on the roof like solar panels. So not critical, pretty important though.
Great, thanks. And I've got a question here from Carl, which I think I'm getting right. He wants to know, he asks, how does this work with continuous insulation? And I think he's referring to the trim details on you were talking about exterior, interior trim details. How does that work with continuous insulation?
Typically, a furring strip is used, or like we outlined before, a hat channel. So if it's got continuous insulation, what I see most typically is hat channels utilized to have something to adhere that siding to.
All right, thank you. And Mark's got a question on light block penetrations. How do you seal a light block penetration if it's installed on top of the panel?
If it needs a sealant, it either gets sealed up with the closure strip for that particular panel, or if it needs some other type of sealant, typically speaking, a color matched polyurethane sealant would be used.
And I think I'm lobbing a softball here, but one of our attendees asks, what are the benefits of using single skin versus ACM?
I mean, I suppose I guess I really don't know the answer to that because I'm not in the installation field, but from a metal siding perspective, I mean, as far as ease of installation is concerned, you know, obviously cost is always going to be a factor. You know, and then aesthetics, I think, drive a big part of that as to why someone would choose a single skin over ACM.
Okay, great, thanks. And a question here about have horizontal metal panels been direct fastened to a rigid insulation board with like rigid insulation with an air barrier such as armor wall without resilient channels between the two? The panel would be secured to the armor wall, not the wall framing, is what he's asking. I think
right. Yeah, I mean, as long as the manufacturer of that rigid insulation has, you know, documents to support a pullout rating as far as fastening something to their insulation is concerned, I don't see why not, but I don't see that in the field, not as of yet.
Thank you. I'll answer this. A number of folks are asking about the availability of the slides. This recording will be available online. You'll get a link to it tomorrow. It'll be there for about a month, I believe. But the slides are under copyright, so they're not going to be distributed separately. That out of the way. Got a question from another attendee. For the underlayment, does it need to be a high temperature rated underlayment?
Not in a siding application, it does not.
And there was another one here I meant to ask. Sorry about this. This might be a little hard to do because he's referring back to a specific picture of the wall to soffit transition, and he says there's a deep reveal, a shadow. It doesn't appear in the detail that went along with that picture that reflects the condition in the photo. And I'm not certain exactly where. Does it? Maybe that rings a bell with you.
No, I mean, I wish you would have referenced a page number or.
All right, I didn't quite get when exactly was talking about.
And it might be that. It might just be a shadow.
Yeah.
That he's seeing in that picture. But a lot of times, you know, where and how the details are made up is it has a lot to do with how those panels lay out and where those penetrations fall in the area of that wall. So there's a lot of afterthought as far as, okay, we need to put a light box in here. What do we need to do to flash this light box? So it's a lot of times it's a field verified or field fabricated trims and flashings for things like that.
Tyler, thank you very much for a great presentation, and thank all of you folks for attending and asking all your great questions. If you want more information, you can go to aepspan.com. Look for the follow-up emails tomorrow with more information about how to follow up. For those of you interested in CEUs and certificates, that will be handled automatically. Please allow 7 days for that stuff to be processed. Thanks everybody for attending. We're doing another webinar on April 7th with MetalCon Live. It's called Metals, Role, and Sustainability. It's a great panel discussion, and it's brought to you by S5. For registration information, go to www.metalarchitecture.com. And then the following week, we're doing another webinar with Steelscape on understanding pre-painted metals. We had a lot of questions today about paint issues, so this would be a good one for you to attend. look for more information on that at metalarchitecture.com as well. All of those events are on our website. Again, Tyler, thanks very much, and thank all of you for attending today. Have a great day, everyone, and enjoy the fresh new spring weather. Cheers.
Thanks, Paul.